Hello. Now we're going to continue our work with binomial expansions, and we're going to take today a little bit more of a focus on this version of the binomial theorem. This was the first one here before we were looking at the expanded version here, which is a little bit easier to read to begin with, but we want to understand what all of these terms mean because they're going to be useful in different parts of the course. So this is our example from before, and just before we jump into the binomial theorem, I just want to remind you of its importance. So we have a plus b to the power of 4, and I've used a formula to figure out what the expanded version of that is. But that's all very abstract, so I just want to take a moment to remind you of what it is we're really talking about. A plus b to the power of 4 means a plus b by a plus b by a plus b by a plus b. It means a plus b multiplied by itself 4 times. So this is a normal power of 4. It means I'm multiplying something by itself 4 times. The reason the binomial theorem is important is because when we want to multiply out brackets, you already know how long it takes to multiply out a plus b to the power of 2, a plus b to the power of 3. In our course, they can ask us to multiply out a plus b to the power of 7 or 10. And if we had to do that by multiplying out brackets individually, it would be pretty much guaranteed we'd make a mistake. So we want to have the binomial theorem so that we are able to keep track of things so that we don't make errors. Now, with that said, and a reminder that we are just dealing with powers on numbers, let's get into some of this notation here and make sure that we're happy with it. So the first thing that jumps out at me here is I have something that kind of looks like a capital E, and it's the letter sigma. And all it means is to add stuff up, to sum up. So the sum of 2 and 3 would be 2 plus 3. Same way as we've used that term since primary school. So we have the sum of all of these terms. So we have an or and an n that are going to be subbed into this formula here, and we have our x and our y that are our first and second term. Now the n is fairly straightforward, it's just the power on the bracket. The or is a number that starts at 0, and it's then going to go 1, 2, 3, 4, 5, 6, 7, up until we hit whatever the value of n is. So it starts at 0, and then is 1, and then 2, and then 3. In this case, n is 3, so we would stop at 3. But that's what our term means. And again, we have n c or is this bracket with the n and the or just kind of hanging around over each other. And a reminder, on our calculator, that's just going to be type in n, in this case 3, and then second function and get the letters, capital letter C, and we're going to end up with n, C, and then we type in whatever the value of or is. It's going to go from 0 up to 3 in this case, and in whatever particular situation we'll have n, C, or is equal to. That's what we're going to put in our calculators. We're going to return to that when we do advanced probability later on. And these are just powers on x and y. So x is going to start out with the power of n because it has or starts at 0. So we'd have x to the power of n minus 0. And the first term will have y to the power of 0. And so on as or gets bigger up to the fact that it gets up to the value of n. So that's the meaning of these terms, explained as best as I can in the abstract. Let's put it into practice. So we're going to have the sum of, we're going to be adding up a bunch of terms, and we're going to start with or equals 0, and this is going to give us our first term. So n is going to equal 3, x is going to equal 3x, and y is going to equal minus 2y. Where am I getting that from? It's from the fact that my bracket here is x plus y to the power of n. So I have x is 3x, y is minus 2y, n is 3. And or is going to start at 0 and keep going 1, 2, 3 up until we get to the value of n. So let's put this into practice. We're going to start out with n, c, or starts out at 0. on our x term is 3x to the power of n minus or is going to be 3 minus 0 on y is minus 2y, and they'll do this in the exams. They will give you terms that have x and y in them when your original formula had x and y in them, pretty much just to confuse you, to double check that you can read things carefully. That's our first term done. Next, or is going to become 1. So then it's going to be 3, choose 1 on 3x to the power of 3 minus 1 on minus 2 y to the power of 1. That's our second term. Third term is going to be 3x to the power of 3 minus 2 on minus 2y to the power of 2, or is now 2, plus 3, choose 3, or is now up at the same value as n on 3x to the power of 3 minus 3, which is going to be 0, and minus 2y to the power of 3. So those are all of the different terms, and I now stop because or has gone up to the value of n. So I now put the choose parts into my calculator because they're just numbers. So 3 choose 0 is just going to be 1. So 1 on 3x to the power of 3 minus 0 is just 3x cubed, which is going to be 27x cubed. And minus 2y to the power of 0 is just 1. So we can put in 1 if we like. Plus 3 choose 1 is 3. 3x to the power of 3 minus 1 is 2, so I would end up with 9x squared multiplied by minus 2y, it has a power of 1. 3 choose 2 is 3 when we put it into our calculator, and I get 3x to the power of 3 minus 2 is 1, so it's 3x on minus 2y, minus 2y squared would be 4y squared. And 3 choose 3 is 1 on, this would just be 3x to the power of 0 would be 1 on minus 2y cubed would be minus 8y cubed. Tidying that up, I get 27x cubed minus 3 by 9 by minus 2, going to give me minus 54, x squared y plus 3 by 3 by 4 is going to give me 24 xy squared. 1 by 1 by minus 8 is going to give me minus 8y cubed. So I can see how I get my terms out this way. So even though that was quite an unpleasant bracket, so long as I followed my method with my binomial theorem, it isn't too bad to be able to work out. I want you to be able to read this in the way that I'm doing it here, but I'm aware that it's easier to read the formula, for most people anyway, in this form, and that's fine too. But we're going to need to know the sum of the sigma notation later on in the course, so it's a good habit to be able to think it through now. But don't panic if we aren't totally comfortable with it. We will be returning to it later. Now, the last thing that they tend to do on exams with this type of question is to ask you for a particular term in the pattern, and really all you have to spot is that if we're looking for the third term, if I write down my different terms here, I'd have x would be equal to a y would be equal to minus 2b. N would be equal to 6. And we're looking for a particular term. So what changes for the different terms? Or changes. The only thing that can really catch you out, in my view, is if you don't look at page 20 in your books, because if you do, it makes it easier to keep track of this. Our first term has or is 0. Our second term has or is 1. Our third term has or is 2. So we just need to be careful. Our third term will have or as 2 because or starts at 0. Once we have that, all you need to do is sub into this version of the formula. So we're going to have NCR on x to the n minus or y to the or. NCR, we have 6C2 on x is a to the power of n minus or, 6 minus 2 on y is minus 2b to the power of or. And when we sub all of that in, we get 15 on a to the power of 4 on 4b squared. Multiplying our numbers and then our letters, we get 60a squared, sorry, a to the power of 4b squared. And just to point out, if that seems a little bit daunting, you are perfectly free to just write out the first 3 terms in this pattern using the binomial theorem normally, and then just pick your third term. You get full marks for doing that. If you can think through the formula a little bit more carefully, it will help you for being able to pick apart more complicated formula later on. So this is a good gateway into some of the more complicated formula that we will have to deal with. But if you're asked for the third term, just work out the binomial theorem as normal until you get to the third term, and then underline that as your answer, and you get full marks for that. So we don't need to panic if this seems a little bit too much right now, but it's a good bit of practice for being able to handle the more complicated formula if we can get our heads around it now. But we will be practicing that type of thing more later. So that's what we need for binomial expansions for now.